In this video, we're going to solve equations that are in quadratic form. So what that means is they don't start out looking like quadratic equations. And if you recall, our quadratic equation in standard form is that ax squared plus bx plus c equals 0, right? So these equations don't start out looking like this, but we are going to identify a substitution. So that means we're going to introduce a new variable that's going to allow us to rewrite our given equation so that it looks like that. Okay, and then once we rewrite the equation, we're going to solve this quadratic equation, this new quadratic equation. But it's instead of solving it for x, it's going to be for this new variable that we're going to introduce called u. And then after we solve for u, we're going to go back and solve for the original x. So let's show you with an example what I mean. Okay, so example 1, you've got r to the 4th minus 20r squared plus 64 equals 0, which is not a quadratic because it's degree 4, right? R to the 4th. But if you write, if I write my quadratic equation, I'm going to write it right on top of it. And I'm going to actually use this new variable u that we're going to be introducing here. So if I write au squared plus bu plus c equals 0, then this is a quadratic equation. Instead of x, it's in u, right? Right? So I'm going to try to get this given trinomial to look like that. Okay, so as I put them run under each other, you might notice that this u landed right on top of the r squared. So that's the substitution I'm going to use. I'm going to let u, my new variable, represent r squared. Okay, and then I'm going to show you that when I square u, because that's what I'm going to need for here, right? It's a u squared. When I square r squared, I get r to the 4th, and that's indeed what I have here. So that's step number 1, is to identify your substitution, which is what are you going to let your u represent, and in this case, it's r squared. And then I'm going to rewrite this trinomial, but in u. So r to the 4th becomes u squared, right? Because we just talked about that. U squared is r to the 4th. Minus 20, and then remember u is representing r squared, and then plus 64 equals 0. So now I have a quadratic equation in standard form, but it's in my variable u instead of my original variable r. So I'm going to solve for u here. Okay? All right. Now, I can solve the quadratic equation at this point with any of the methods that we've seen before. We've seen factoring, and we've seen quadratic formula. Those are the two I would recommend. Unless the middle term is 0, then we could use square root property, right? And completing the square is usually my last resort because quadratic formula comes from completing the square. So turns out that this guy factors. Two numbers that multiply to 64 and add up to a negative 20 is u minus 16 and u minus 4. Okay, and so these add up to negative 20 and they multiply to 64. So now here I'm going to solve for u. Set these to 0 with the 0 factor property, and I get u equals 16 or u equals 4. But now don't stop here, because now you go back up here and remind yourself, right, that u was r squared. So now we're going to substitute r squared equals 16 or r squared equals 4. Now I have to solve this quadratic. Okay, but now this quadratic is quantity squared equals number, right? Quantity squared or variable squared equals number. We usually solve that using square root property. Square root property. So we're going to take the square root of both sides and remember the plus or minus. So r equals plus or minus square root of 16. R equals plus or minus 4. Or r equals plus or minus square root of 4, r equals plus or minus 2. So our original fourth degree polynomial has 4 roots, and they are -4 and +4, -2 and +2. Okay, and you can check those in your calculator. All right, let's go to the next one. So the next one's similar, isn't it? The c to the 4th minus 26c squared plus 25. So let's go ahead and do that. And again, we are going to, if I put my quadratic right on top of my problem, I can see that the u is going to be c squared. So let's let u equal c squared. And when we square c squared, we get c to the 4th, which is what we have here in the first term. So we're going to substitute u squared for c to the 4th minus 2u for c squared plus 25 equals 0. I'm sorry, and there's a 26 here. So minus 26u plus 25 equals 0. So now solve this quadratic, which also factors. U minus 1, u minus 25 equals 0. U minus 1 equals 0, or u minus 25 equals 0. So here I get u equals 1, or u equals 25. But that's u. We need to solve for c. So come back up here and substitute c squared equals 1, or c squared equals 25. And square root property for both of these. So c equals plus or minus square root of 1, which is 1, or c equals plus or minus square root of 25, which is 5. So 4 solutions, -1, 1, -5, and 5.